All right, so continuing with more week 7 homework problems. The last problem we looked at was number 27. This problem here was number 28. So it says to solve the problem, write and solve a proportion. So refer to the illustration below. A St. Bernard website lists the ideal proportions for the height at the withers to body length as 5 to 6. What is the ideal height at the withers for a St. Bernard whose body length is 35 and 1/2 inches? All right, so first off, guys, as I said last time, it's always good to find the question. So it says, what is the ideal height at the withers? So that's what we're going to be solving for here, the ideal height at the withers for a St. Bernard whose body length is 35 and 1/2 inches. All right. Well, up here, guys, notice that it says exactly what type of proportion we are looking for. It says ideal proportions for height at the withers to body length. All right, so I think I'm going to write this one out here. So we have height at the withers to body length. All right, so this is the proportion, this is the ratio that we are going to be looking at. Height at the withers to body length. So remember that this colon here, or you can just use the word to, T-O, or you can use a horizontal division bar to create a fraction for a ratio. So what we'll have here is height at the withers in our numerator to body length in our denominator. And it tells us in the problem, per this website, the ideal proportions, or the ideal ratio, is 5 to 6. Height at the withers to body length, 5 to 6. All right. So we have 5 to 6. Okay, so once again, that is height at the withers to body length. Height at the withers in the numerator, body length in the denominator. So we can set up a proportion then to help us figure out the answer to our question, which is, what is the ideal height at the withers? What is this ideal height at the withers? We do not know. We're going to solve for it. If the body length is 35 and 1/2 inches. If our body length is 35 and 1/2 inches. All right. So here are our two ratios. In other words, here is our proportion. Height at the withers to body length. Height at the withers to body length. Must be equal to height at the withers to body length. All right, so as I said last time, it's always important to make sure that your ratios are set up in the same way. All right, so now that we have these set up, let's go ahead and let's take care of this mixed number down here and rewrite that as a fraction. So we have 5 over 6 is equal to x all over. So 35 and 1/2. If you want to rewrite this mixed number as a fraction, take the denominator 2 and multiply it by the whole number 35. 2 times 35 is 70. And then add whatever you have in your numerator. 70 plus 1 is 71. So that's the value that goes in your numerator. Keep your denominator of 2. We have 71 over 2. We are now ready to cross multiply. All right, so cross multiplying here, we're going to get 6 times x, which is just 6x, is equal to, and then multiplying on our other diagonal, we have 5 times 71 over 2. Let's do some side work over here. So we're going to have 5, aka 5 over 1, times 71 over 2. So we've got 71 all divided by 2. So remember, when you're multiplying fractions, guys, we are just multiplying straight across. Numerator times numerator, 5 times 71. Let's get some help here. Clear that. 5 times 71 is 355. All divided by denominator times denominator. 1 times 2 is 2. So 355 all over 2. Okay, so now we are ready to go ahead and solve for x. And we're going to do this by getting x by itself. So notice that x is connected to this 6 through multiplication, so we're going to have to divide to undo that multiplication. And whatever we do on one side of our equation, we have to do to the other to maintain our equivalence. So 6 divided by 6, those cancel out. All we're left with over here on the left-hand side is x. And we need to perform this division over here on the right-hand side. So we have our fraction, 355 over 2, and we need to divide this by 6. So we need to take 355 all over 2, and we need to divide by 6, aka 6 over 1. Alright, so remember, guys, dividing by a fraction is the same as multiplying by this fraction's reciprocal. So this is the same thing as 355 over 2 times 1 over 6. Alright, so dividing by 6 over 1 is the same as multiplying by 1 over 6. So let's see what we get here. Multiplying straight across, 355 times 1 is 355. All divided by 2 times 6 is 12. Right, so we get down here, just a reminder where this came from. So remember, we have x on the left-hand side is equal to, and when we divided 355 over 2 by 6, we got 355 all over 12. 355 all over 12. All right, I'm not sure if that can be reduced. Let's take a look at it as a fraction. 355 divided by 12. It's the same thing as 29.583 repeating. Equals 29.583, and that 3 is repeating. We can signify that by a bar over the 3. Let's see if they said anything about reducing our fraction. It doesn't say anything about reducing the fraction, guys, so hopefully the answer of 355 over 12 would have been accepted for that problem. And let's keep in mind what our dimensions were. Let's see here. St. Bernard, 35.5 inches. So this would be in inches as well. Units are important here. Keep that in mind. All right. So the next problem then, problem number 7 was the next one on the list. Let's take a look at it. So for problem number 7, it says to write the ratio as a fraction in simplest form. So we have 1 1/3 to 9 1/3. So let's take a look at that really quick. All right, so we have 1 1/3 to 9 1/3. All right, so what we need to remember here, guys, is that ratios can be written as fractions, right? You can separate the two values in a ratio by this word, to, T-O. You can separate them by a colon, all right? Or you can write these two numbers vertically. You can stack them vertically and separate them by a horizontal bar, the division sign. So this is the same thing as 1 1/3 to 9 1/3. All right, and we can go ahead and simplify this fraction first by rewriting these mixed numbers as their fraction equivalents. So 1 1/3, that is the same thing as the denominator 3 times the whole number 1. So 3 times 1 is 3. Add the numerator, add 1. 3 plus 1 is 4. So that's the same thing as 4/3 in our numerator, divided by, we have 9 1/3 in our denominator. So take your denominator of 3, multiply it by 9. 3 times 9 is 27. Add your numerator. 27 plus 1 is 28. So we have 28 all over 3. All right. So now notice that you're taking 4 over 3 divided by 28 over 3. All right. Well, dividing by a fraction is the same as multiplying by the reciprocal. So 4 over 3 divided by, that's this horizontal line, divided by 28 over 3. That is the same thing as 4 over 3 times 3 over 28. Okay, so really quickly, guys, a good trick to remember about multiplying fractions. Right? If you are multiplying two fractions, you can do what is known as cross-canceling. If there is a factor that you find in a diagonal, for instance here we have 3 and 3, you can cancel that factor out. All right, on this diagonal, notice you have the numbers 4 and 28. These two numbers contain a factor of 4. So if you take 4 away from 4, that leaves you with 1. If you take a factor of 4 out of 28, that leaves you with 7. All right, and you still have just 1s here for your 3s. So we have 1 times 1 in our numerator, and that is just equal to 1. All divided by 1 times 7 in our denominator is just 7. So the answer for our first one should be 1/7. We see that's what we get here. Let's see if we can do this next one. Just to show it again, so we have 6 1/4. I'm going to go ahead and just write it as a fraction right away. 6 1/4 to 1 1/4. Running out of time here, so I'm going to kind of go quick. So first of all, rewrite these mixed numbers as fractions. 4 times 6 is 24, plus 1 is 25, all over 4. And 4 times 1 is 4, plus 1 is 5 over 4. All right, so we have 25 all over 4. Divided by 5 over 4 is the same thing as times 4 over 5. And since we are multiplying two fractions, we can cross-cancel common factors. So we can cross-cancel these 4's. In other words, you're dividing a 4 out of both of them. They become 1's. And you have 25 and 5 on this diagonal. You can factor out a 5 from each of those. That 5 becomes a 1. That 25 becomes a 5. multiply straight across, 5 over 1